Hey guys, welcome again to the Maths Club. So in continuation with our series on set theory, we'll be looking at the three-set Venn diagram and how we're able to shade whatever we want. We also do something similar for the two-set Venn diagram. So we're doing basically the same thing for the three sets. Without further ado, let's get started. So the first shading we're going to talk about is, so we have three sets. I want to shade the intersection between the three of them. So if you have this set A, set B, set C, where do the three of them intersect? So this is circle 1, this circle 2, this circle 3. We can see that there is a sweet spot here, right, where the three of them actually intersect. So let's see. Great. So when we're looking at the intersection between the three of them, it is this particular middle. The second one we're going to be looking at is the union. So we have this set A, B, C. We want to find the union of A, B, and C. Remember, union is just everything inside without repetition. So you agree with me that I'll just be shading everything inside all these three circles. And we can see, so this is how we represent the union of three sets. Now look at this one. We have A intersection B complement intersection C. So the way I always look at it, I find it very interesting, right? What I always do is that I always ignore the one that has complements first. So it's basically just saying A intersection C, right? So where is A and C? This is A and C. Where do they meet? They meet at this place here, right? So if you look at this place, this is where A and C meet. So if I remove this circle for B, you see that this of them they meet here. Now it's not saying that in the place where they intersect, when you see B complement, just look at it as that it doesn't want B, right? So in this intersection between A and C, it doesn't want anything that has B. Remember, this place here is intersection of A, B, and C. So that means that in this small space here where we talked about the intersection, there will be some elements that come from B, right? Because B is, if you look at this place, it's like the common point between A, B, and C. But because we don't want anything at all that has B in this our intersection of A and C, we are going to exclude the intersection of A, B, and C, right? So let me come again. We had A intersection B complement intersection C. I said ignore the B complement and just focus on the real ones, which is A intersection C. So if I remove this place, I'll have intersection. If I look at this, this is my circle A, this is my circle C, right? This is the point where A intersects with C. But because we are going to intersect it with B complement, right? In this center here, there are some B elements because this is the intersection of A, B, and C. So for me to not have anything at all that has an element of B, right, I will exclude this place, which is the intersection of the three of them, from my intersection between A and C. So at the end of the day, this shading should just be just this place where my arrow, you should follow my mouse. So it just be this place. And if you look at it, that's just basically it. So let's see the next one. The next one is saying A intersection B intersection C complement. Like I said, always ignore the C complements when you're trying to see. I'll just ignore this intersection C complements. A and B, where do they intersect? This is circle A, this is circle B. Circle A and B intersect in this place here. But if you look at it, it's saying that it does not want anything that has to do with C. Also, remember this place here is the intersection of A and B and C, meaning that in this place there will be some elements that are common to C, right? And this is where our A intersection B is. So if I want to remove anything that has to do with C, I have to remove this place here, because whatever is here is common in A, B, and it's common in C. But I want what's common in A and B without what is common in C. So that means at the end of the day, it's just be this upper place here that I would be shading. And we see that that is actually correct. So let's look at this one too. So it's the same thing too. I want you to pause and try it out yourself and see what you would get. Welcome back. Like I said, always ignore anything that has complements. I'll just ignore this A complement intersection. I'll ignore it. I'll just focus on B intersection C. B and C, they intersect in this place here, right? Now, we are saying that we don't want anything that has to do with A. This portion here has elements that are common to A, B, and C. So because there are elements that are common in A, I will just remove this one here. So at the end of the day, it's just be this place that will be shaded. Great. So if you got it, well done to you. Another way to look at this is that what is the intersection of B and C without A, right? Where do they intersect without intersecting with the A sets? Now look at this one. We said we want like I said, always ignore anything that has complement. So I'll just ignore all this place. So it's telling me to shade A. So shading A is the full circle. So I'm going to shade this full circle of A. But now we're saying that it does not want anything to do with B. So that means that where is B inside this A? B is like there's some intersection with B here. So I have to remove this place here because it does not want anything to do with B. And it does not want anything to do with C. So I have to also remove this C. So look at this C circle. I'll remove anything that has to do with C here. So at the end of the day, from that full shading, it is just this outside here that remains. And this is also similar to, if you look at what we're doing, two sets Venn diagram, what we'll be saying A only, right? This is the same thing as saying A only. And if you look at the shading, it is as it should be. Now, this seventh one, I want you to pause the video and try it out yourself. Welcome back. Like I said, always ignore all the complements. So I'll just ignore A complement, intersection, B complement, intersection. So it's just saying shade the entire thing of B. It's now saying take anything that has to do with A. Look at this circle A. So I'm going to take out this place here and take out anything that has to do with C, right? Because C complements. So look at where C is. I also take out anything that has to do with C. So at the end of the day, you just see that I'll be left to this part here shaded, which is what we have. Now the same thing too for this one. You can pause the video and try it out yourself. Welcome back. So this one is saying just shade everything in C, but remove everything that has to do with A and remove everything that has to do with B. So you see that I'll be left with what? C only. Now look at this. This one is saying A union B union C, but it's telling me to find the what? The complement of it. We know what A union B, you know, remember this is complement, like saying everything in the universal set that is not in A union B union C. Remember this border here. This border here is our universal set. Everything inside this border here is our universal set. So if we are trying to find A union B union C, that is everything inside all this circle. So what is not inside this circle will just be everything else around it. So if I want to shade, this is how I will shade it. Just saying every other thing else apart from A union B union C. So now let's look at some examples. So in the first example, it says that we should describe the shaded portion in the diagram. What do we see? We see that it is at location Q, right? What I can see is that nothing about P is shaded and nothing about R is shaded. So we can say P complement intersection Q intersection R complement. It's always good to always start with like the first, which is P Q R. Don't say Q R P. No. So P complement intersection Q intersection R complement. Let's see if we're correct. Great. So this P complement intersection Q intersection R complement. Now the second example says that the Venn diagram represents three subsets P, Q, and R of the universal sets U. Copy the Venn diagram, shade and indicate the regions represented by. So this is P intersection Q complement intersection R. So if you look at it, I want us to actually do this mentally. So I said always try to ignore like the, if it's in like 3, you are giving P, Q, and R only. Just ignore the one that has complement. So you are shading P intersection R first. So P intersection R, this would be all this place here, right? As not saying intersection Q complement, that does not want anything that has to do with Q. The only thing that has to do with Q in this place here is where P, Q, and R all meet. So that means that if I take that away, it's going to just be this place here. That should be our answer for this particular place. So I will assume that it is this area that we are shading. Now for the second one, it says that P complement intersection Q intersection R complement. So I'm going to go to Q, and anything that has to do with P, I will remove it. Anything that has to do with R, I'll remove it. So I'm assuming that our answer will just be this place here. So it will be this place here, which is Q only, and then this place here, which is P intersection R only. Let's see. Great. So you can see P intersection R only and then Q only. So in summary, what have we been able to see? So if I have a 3-set Venn diagram like this particular place that I shaded is my what? A intersection B. Great. This particular one, this place that I shaded is my what? B intersection C. Great. This other place that I shaded is my what? A intersection C. Now, if I were given this Venn diagram again, this particular place, can you see just this place here is my A intersection B only. This place here is my what? A only. This place here is my what? A intersection C only. You can see that it's not including the ones that are common to all of them. It's just A intersection C only. This place is my what? C. This place is my what? B intersection C only. So this is my B only, right? And then this middle guy is the A intersection B intersection C. So this particular distinction is very, very important when you start solving questions. So A intersection B and A intersection B only are two different things, just like when we're doing two sets Venn diagram. So with this, we've actually come to the end of the Venn diagram shading when we have three sets. In the next video, we'll be looking at some examples that will bring this home. We'll look at some examples that we'll solve mathematically, and then we'll solve using Venn diagram. If you have any question, any suggestion, any feedback, you can drop it in the comment section. If you like this video, you can click on the like button to encourage our ministry, right? And if you know somebody that this can help, please spread the word. Remember, our aim is to reach as many people as possible. See you guys in the next video.